I did my project on explanatory regression analysis of crime trends in Richmond, Virginia. What elements can influence crime hotspots? Is it population density? A lot of people in a small area tend to lead to problems. Is it income, education level, renting versus owning housing, offender age or sex, unemployment, race? Study area is Richmond. It's the capital of Virginia. Some fun facts: population is 226,000. It's about 60 square miles, so it's a small city. About 20% of the citizens live in poverty here, and over half rent housing instead of owning it. Median income is a little over 50,000. And we do have 3 universities here, VCU, which is the largest, under 30,000 students. And then we have 2 private schools, the University of Richmond, under 4,000 students, and Virginia Union University with 1,600 students. And the questions I was looking at were, do violent crimes and property crimes share the same distribution and hotspots in Richmond? Violent crimes are murders, assaults, robberies, sex offenses. Property crimes are larcenies and burglaries. And then I wanted to see if there are any relationships between the crime and the neighborhood socioeconomics and demographics. The data I used were 2020 and 2021 Richmond crime data for our dependent variables. They were broken down by neighborhoods. There are about 148 neighborhoods. And the socioeconomics and demographic data that I looked at were median household income, population density, minority population, education level, and renter versus homeowner. And this is the distribution for violent crime in Virginia. We do have some hotspots over here. This part is where VCU is, and a lot of the outlying areas is where students live. Over here, we have a lot of the public housing areas, and the last few years, they've had a lot of gang wars. So violent crimes would be higher there. And this is property crimes distribution, pretty similar, just more spread out compared to the violent crimes. Again, VCU is the top spot for property crimes. These areas here are both like strip mall areas. And this is the population density, a lot of it towards Richmond. The VCU area, a lot of apartment buildings over here for the students. Again, a lot of the public housing over here in the east. And this is the renting percentage for distribution. Pretty much most of the east side is 60%, 80 to 80%, mostly rentals, compared to the eastern part over here, which is mainly one family owned houses. This is medium house income distribution. A lot of the wealth is pretty much in this eastern corner or western corner up here. These are a lot of the $1 million houses that we see. A lot less wealth in this area over here and to the south. This is minority population distribution for Richmond. Richmond does have a large minority population. Approximately 46% is African American, 45% is whites, 2% is Asian, and pretty much 4% is 2 or more races. We do have a large population in the south and towards the east. Education level distribution. I looked at residents who had high school education or less. So there's going to be kind of in the southern region and more to the eastern region. And for my methods, I used the exploratory regression tool to figure out which of my explanatory variables made the best model for violent crimes and property crimes. And both found that population density, renter percentage, and education level were the best model. I then ran the ordinary least squares tool to ensure that if crime was influenced by those variables, and the spatial autocorrelation tool to see if there is any spatially autocorrelation or statistically significant results. Results for violent crimes, approximately 33.5% of violent crimes were explained by the explanatory variables, not very high. The Kogenar statistics show that there is heteroscedasticity, which means the model was not consistent throughout the neighborhoods. So neighborhoods low on crime did much better in the model compared to neighborhoods with higher crime rates. The Jer-Bara statistics show that the model is biased, meaning we did have some key variables that we did not include. And then we ran the Lobo-Morrison tool, and that showed random distribution. And here's graphic representation. You can see the higher the amount of crime or lower amount of crime, it just got further and further away from the prediction. And this is just a graphical representation of this chart. For property crimes, we found that approximately 18.5% of crimes were explained by the explanatory variables, not very high. That means over 80% of the property crimes that we saw were not explained. It also showed heteroscedasticity and that there were key variables missing, and there was random distribution also. It's not as bad as the violent crimes, but there were a lot of outliers that were 3 to 4 to 6 deviations away from the mean. So is there a relationship between crime and neighborhood socioeconomics in Richmond, Virginia? Possibly, but with poor adjusted R-square values of 34% for violent crimes and 18% for property crimes, the model biases due to skew distributions, the missing key variables. I would not rely on these regression models to make that assumption. There needs to be a lot more work involved. I also found some of the explanatory variables that I used did not show strong linear regressions or linear relationships with the dependent variables. One of those was education. It was pretty much almost flatline. Next steps, definitely we need to add more explanatory variables to this model. Offender data, which usually is not public, would probably have helped a lot. Repeat victimization, is there a place or person targeted more often, and we need to figure out why is that. Distance to police stations, does police presence hinder crime, or does it do anything? Using pre-COVID crime data probably would have helped, because when COVID hit in 2020, a lot of stats just changed. Like, they were just completely different from the year before and the year after. So that might have messed up some of this analysis. We could also have tried using nonlinear regression analysis techniques. And we could have transformed the skew data and removed outliers before we did the linear or the linear regression.